All right, class, starting with the revision. Now, in the last class, we have done the revision of mechanical properties of solids. Now, we'll be doing mechanical properties of fluids. All right. So, when we talk about a fluid, what is a fluid? Fluid is a substance that can flow. All right, it assumes the shape of the container. It assumes the shape of the vessels. That's it. What you have to remember about a fluid. And yes, if characteristics are asked, then you have to tell that atoms and molecules in a fluid are arranged in random order, and they do not have their own shape. They take the shape of the container in which they are put. And one thing that you have to remember is that liquids and gases both are considered as fluids. It's not just that liquids are only fluids. So we have in our lesson two types. If the fluid has stopped, we say this is hydrostatics. And if the fluid is in motion, we say this is hydrodynamics. Clear? Then first concept that you have is the concept of thrust. So basically thrust is the perpendicular force that is acting in the substance, right? Suppose if I take a container, all these molecules are moving. So while moving, while colliding, these particles collide with one another, as well as they collide with the walls of container, and they exert a perpendicular force, which is known as thrust. Thrust is nothing but perpendicular force. And when we take this force per unit area, we get a quantity which is known as pressure with the SI unit of pascals. You can use Newton per meter square. There is no harm in using 1 Newton per meter square. 1 Newton per meter square is equal to 1 Pascal. So any of these relations you can use. Then basic applications of this you should be aware of. I'm not going to discuss any numerical from this because all these are formula based questions. One more thing that you have to keep in mind while practicing fluids chapter is that the concept of density. Density is mass by volume. So this is also used. So you should remember the densities dimensional formula, that is ml to the power minus 3. Correct? Then we have the concept of specific gravity. Specific gravity is also density, but this is the relative density. Specific gravity is basically the relative density. Whenever we are talking about a relative density, we use the term specific gravity, right? So it's the density of a substance by density of water. The questions from this topic is also very basic, very easy to be discussed. Then you have an important law which can come in your exam, that is the Pascal's law. I'll give you time to write down everything. Don't worry. First, just understand. This is known as the Pascal's law. What is the Pascal's law? It tells how the pressure will be transmitted in a fluid. Understood? Pascal's law tells you how pressure can be transmitted in a fluid in a number of ways. Possibility is that in a number of ways. Firstly, you should understand that the pressure being exerted, this is equally transmitted in all directions. Pressure that is being exerted is equally transmitted in all directions. And if the fluid is at rest, suppose these are the 3 different types of containers which I have taken. And till this level, I am filling all of these. All these have been filled to up to this level. So Pascal's law says the fact that all these pressure PA, PB, PC, all these will be equal if the fluid in them is at rest. This is the Pascal's law, which you have to remember. It's a very, very, very important law. Basically, whatever will be the force here, area here will be equal to the force on B by the area of B will be equal to the force on C by the area of C. This area of A, area of B, area of C. All these pressures, that is PA is equal to PB is equal to P. Clear? This is how you have to take. Then under the applications of it, you have a very important concept that is known as the hydraulic lift. Hydraulic. This is hydraulic lift. So this is a device used to lift heavy objects like vehicles. One end is very narrow, like this, and other edge is very huge, like this. And over this larger edge, the car is placed. Here you have the car placement. A small force is applied, which is transmitted equally, so this becomes greater over this edge. That is the concept of hydraulic lift, which you should be aware of. In your exam, I have seen one question paper in one of the schools where this question was asked that with the help of diagram, label diagram, you have to explain the working of hydraulic brakes. So just pay attention just in case if it comes in your school. Hydraulic brakes. See, what is a hydraulic brake? Hydraulic brakes are used in the automobiles, in the vehicles, and they work on the Pascal's law of transmission, which you have seen. Now, how are they constructed? What is the construction? So firstly, there is a tube. All right, this is a tube which is present. Fine. And at the end, it has a master cylinder. Over its edge, it has a master cylinder. Why does it have a master cylinder? Because it has to contain the brake oil through the tube. So this is the master cylinder, which itself consists of here. This itself consists of brake oil. Now further what? One end of this tube, this is connected to the master cylinder, that is fine. But in order to utilize it, it is placed with a help of a piston. Piston, you understand? Like the syringe. In the syringe where you press it and like the cases of syringe, where a piston is present, a movable device which is present to compress air. So likewise, a piston is present with a lever system. And this is further connected to the brake paddle system of the vehicle. So what all things are there? This is the lever system. Lever system. This is the piston, which is further, this is connected to the brake paddle. All right, this is connected to the brake paddle. Now this tube further, this is connected because one more edge is present. See, one edge is this, second edge, where will the hydraulic lift principle will act? So here you have the pistons. These are also again two pistons you have. Now, these are connected to the wheel cylinders. These pistons, these are connected to the These are connected to the wheel cylinders. But we are only aware about the brake and the wheel. In between this occurs. So when the pressure is a small little pressure is applied on the brake, when we are moving the vehicle and we want to stop the vehicle, a small pressure is applied. But the wheel which was moving with such a large speed, how was it able to stop? The reason is that when a small force was applied over here, the force transmitted equally and the force increased to a very large volume which stopped the wheel from moving when the pedal is pressed. This is what you have to remember. That's it. Before we start with the pressure through the liquid column, one question, let us practice. But of course, I want you to have a look through the theory points and write down the hydraulic lift. See, this question says that two pistons of hydraulic press have diameters 30 centimeters and 2.5 centimeters. What is the force exerted? The question is you have to calculate the force by the larger piston when 50 kg weight. 50 kg weight means you have to convert this into Newton. Is placed on the smaller piston. If the stroke of the smaller piston is 4 centimeters, through what distance? Now you have to calculate the distance. Will the larger piston move after 10 strokes? Number of strokes are mentioned. So in this question, how will you calculate? See, firstly, the radius part. This has the diameters. Smaller one, 2r is equal to 2.5 centimeters. So firstly, we'll find out the radius, that is 1.25 centimeters. Coming to the larger diameter, that is 30 centimeter. So larger radius will be 15 centimeters, correct? Now, force is given as 50 kg weight. Keep it like this. What about the other force? This is missing, which you have to calculate. So see, radii are mentioned. One force is mentioned, only one force is missing. It means force of smaller piston by area of smaller piston is equal to force by larger piston by the area of the larger piston. That's the whole concept. So how will you write the area of the circle? Pi r square, small r for the smaller piston, is equal to pi capital R square. Pi will be cancelled. See, small f radii you just want to find out this, that is unknown. So if we substitute, this will be capital F will be F into capital R square by small r square, which is equal to 50 multiplied to 15 by 1.25 whole square. This will come out to be around this is 50 into 144, so this will be equal to 7200, but not Newton. This will be in kg weight because here we are taken this in kg weight. Secondly, in this question only, it's asking you the distance. See, force traveled into the length, this is the work done. Force into displacement, this is the work done, is equal to force by the larger piston into the distance by the larger piston. Here also distance by the larger piston is unknown. So capital L is equal to F into small l by capital F. This is equal to 50 into 4 by 7200, which is equal to 0.028 centimeters. So distance through, and yes, one more thing, this has mentioned in the question that what happens after 10 strokes. So after 10 strokes, this will be 10 into 0.28, which is equal to 0.28 centimeters. This has to be the final answer. Write it down. Next that we have is the concept of pressure exerted by the liquid column, which is H rho G. So this derivation also can come in your exam. All right. Basic questions from this can be asked. What you have to remember here is that total pressure is equal to absolute, the atmospheric pressure, sorry, plus the gauge pressure, that is H rho G. Now see what is meant by every term that I have written. This P is the absolute pressure. Absolute pressure means the total pressure of the system. PA means PA we can write, or P naught, that is the atmospheric pressure, which is represented as P naught also, 1.01 into 10 to the power 5 pascals. And this concept is known as the gauge pressure. That is the pressure exerted by the liquid column. This is important in this. Rest you can calculate. This is the most important portion from this. Height of atmosphere can be asked through the density of atmosphere, that you have to remember. SI unit for atmosphere will also be the same. One numerical from this, quickly just look at this, then one numerical from this. See, this says that what is the absolute and gauge pressure of the gas above the liquid surface. In the tank shown in this figure, density of the oil is given 820 kg per meter cube, and density of mercury is given as 13.6 into 10 to the power 3 kg per meter cube. One atmospheric value is already given. Markings are also made. This is mercury, this black portion, this here is mercury. This is the highest level which is placed. This is the lowest level that is placed, A. Differences in height is already given. One thing which you can notice from here, this is PA, this is PB. That is both the pressure levels are same. So according to Pascal's law, PA will be equal to PB. Now what is PB? We can say further PA is equal to pressure, the atmospheric pressure, plus 1.5, this length height, plus this height for the oil part, So that is plus 1 into H rho G. Rho means density, that is 13.6 into 10 to the power 8. And G, or no, here it is given no 820 density of oil. And we're talking about oil. So this will be into 820, acceleration due to gravity 9.8. In the question, it can be given that take G as 10, but here it is 9.8, so we are taking it as 9.8. Pressure, second pressure. That is the pressure of the mercury. So this is pressure, total pressure plus. This is 1.5 plus 0.75 multiplied to what is the density of the mercury? Density of mercury is given as 13.6 into 10 to the power 3 into G, that is 9.8. How do you calculate the net pressure? Net pressure means you subtract both of these, correct? P minus P dash. So see, when you are subtracting these two, this P minus P dash, this is equal to 2.25 into 13.6 into 10 to the power 3 into 9.8 minus 2.5 into 820 into 9.8. So this is equal to 3 into 10 to the power 5 minus this, when you will solve, this is 0.2 into 10 to the power 5. This is equal to 2.8 into 10 to the power 5 pascals. This is the value of the net pressure that is present. When you are calculating the gauge pressure, from here, this is the pressure difference, that is P minus P dash. When you're calculating the gauge pressure is what? That is the absolute pressure minus the atmospheric pressure. So absolute, when we're talking about the gauge pressure, that is absolute pressure minus the atmospheric pressure. This is still equal to 2.8 into 10 to the power 5 pascals, because this is exactly what we have calculated here. So they are the same. But when we are talking about the absolute pressure, that is the gauge pressure plus the atmospheric pressure. Absolute pressure is this. That is 2.8 into 10 to the power 5 was the gauge pressure. Absolute atmospheric pressure will be 1.01 into 10 to the power 5. So this is equal to 3.81 into 10 to the power 5 pascals. That is the answer. Write it down. Okay, now the next concept that we have in under hydrostatics, that is the concept of buoyancy. So buoyancy, what do you understand by the term buoyancy? It's the force. A buoyant force is the force that acts through the center of gravity of the displaced fluid, which is known as the buoyancy. Now, the upward force which is acting on your system, this upward force is known as buoyant force, and the phenomena is known as buoyancy. Right? When a body is immersed in a fluid, the fluid exerts pressure on all the faces of the body. Here also, here also, here also, on all the faces of the body. All right. But the force, but this pressure increases with depth. So up thrust or upward a force acts on the outermost surface. Because of the bottom is because of this greater depth, there has to be a force that acts in the opposite direction. This is known as the buoyant force. Then apart from buoyancy, you have the concept of Archimedes principle. You have the concept of Archimedes principle. In Archimedes principle, two things are very important to remember. One is that the buoyant force is equal to V, volume of the body, density of the liquid into G. Apart from this, second thing which you should remember is apparent weight is equal to actual weight 1 minus rho by sigma. Rho is the density of body, sigma is the density of liquid. Then laws of flotation, you should remember, when weight is greater than the buoyant force, when the weight is equal to the buoyant force, and when the buoyant force is greater, in which case will your body sink. All right. One or two questions, let's see from this topic also. Hmm. Yes, class. See, this says that a solid body is floating in water. This has 1/6 of the volume above the surface. What fraction of its volume? We have to find out the fraction of its volume will project upward if it floats in a liquid of specific gravity 1.2. So specific gravity, that is the relative density of the body. So we have to find out its fraction of volume. So for that, we have to know the volume of the body. So volume of the body, this is equal to V meter cube. Then volume of the body that is lying above the surface. What it is saying, a solid body floating in water has 1/6 of the volume above the surface. So volume of body above the surface is V/6. So how much is displaced? Volume of water that is being displaced, this is V minus V/6, that is 5/6 volume meter cube. See, weight of the body, this is equal to the weight of water displaced. So weight of the body, this is equal to V rho G, and weight of the water displaced, which we have calculated it 5/6 of V. So density is 10 to the power 3. Acceleration due to gravity is G. So 5/6 into V into 10 to the power 3 into G. Now see, let's say V dash is the volume that lies outside. V dash is the volume of the body that lies outside. And specific gravity is already mentioned, that is 1.2. So this means that volume of liquid displaced, this is V minus V dash. So when we're talking about the weight of the body, this is equal to weight of liquid displaced. This is equal to weight of liquid displaced. So this is equal to V rho G is equal to V minus V dash into 1.2 into 10 to the power 3 into acceleration due to gravity G. So when you equate both these equations, you get V minus V dash into 1.2 into 10 to the power 3 into G, which is equal to 5/6V into 10 to the power 3 into G. So acceleration due to gravity, Gg, this is cancelled. V minus V dash by V, this is equal to 5/6 into 10/12, which is equal to 25/36. But we don't have to find out this. We have to find out the fraction. So for fraction, we'll be separating these terms. So V by V will be 1 minus this will be V dash by V. Right? We are just separating the term because we just want this. This is equal to 25/36. So V dash by V is equal to 1 minus 25/36. That is equal to 11/36. Write down the solution. See, this question says that a spring balance reads 10 kg when a bucket of water is suspended from it. What is the reading on the spring balance when an ice cube of mass 1.5 kg is put into the bucket? An iron piece of mass 7.8 kg suspended by another spring is immersed with half its volume inside the water in the bucket. Relative density of iron is given as 7.8. See, when the ice is put into the bucket, its total weight will be the spring balance weight, that is 10 kg, plus the additional ice cubes weight, that is 1.5 kg. So this total becomes 11.5 kg of force, right? So this is exactly what the spring balance will be showing. Second part, so this is the first part, reading of the spring balance. Second part says that an iron piece of mass 7.8 kg suspended by another spring is immersed with half its volume inside the water in the bucket. See here, for the density of iron, we have the relative density into the density of water. So relative density into density of water. That is 7.8 into 10 to the power 3 kg per meter cube. So volume of iron piece, this will be mass by density, right? Mass by density. So mass is 7.8, density we have calculated, that is 7.8 into 10 to the power 3. So 7.8 will be cancelled. This will be 0.001 meter cube. Now see, this is saying only half of the iron piece is being immersed. So volume of displaced water will be volume of water displaced will be half of it, 0.001 by 2. Now, when we are calculating the upthrust, so this is equal to the weight of water displaced. This is equal to weight of water displaced. So that is volume will be 0.01 by 2. Density will be 1000. This is G. So final answer is 0.5 gram Newton. Or you can say this is 0.5 kg force that is being applied. If this is 0.5, so in the spring balance, total will be 10 plus 0.5, which is equal to 10.5 kg force. This is in the spring balance. Spring balance reading. Note it down.